G'day guys, Mr. Bennett here. Today what we're going to do is just recap first of all the idea about the discriminant, and so this is just taken straight out of your textbook. So we've got this particular function here. If we work out the discriminant there, it works out to be -8. And when we have a discriminant less than 0, it means it doesn't cut the x-axis, and you can see in the graph here that's what it actually does. Alright, so that sort of matches with what we've been told in the previous video. If the discriminant is equal to 0, so in this particular case, putting in our values, you get a discriminant of 0, and so therefore what it means is it touches the x-axis. Right, so it's cutting the x-axis or touching the x-axis at 1. So we have one repeated root, and the function touches the x-axis. Over here, if you've got the discriminant greater than 0, which we have over here, we've got a discriminant 16, then what actually happens here, it means that it cuts the axis at two different points, here at -1 and 3, which are in fact the factors of the equation there. Right, so keeping that in mind, right, so we know the discriminant, if the discriminant basically is less than 0, it doesn't touch the axis. If it's equal to 0, it touches the axis, and if it's greater than 0, it cuts at two places. What we're going to do in this video is look at determining the quadratic function from its graph. Okay, so we're going to do the two things. Now, the two equations that we need to relate to, the two forms, we've got this form over here, which is y So we've got these two forms here. So we've got the form of y equals a x take alpha x take beta, right? And then we've also got the other form, which is y equals a x take h squared plus k. So those are the sort of things that we're going to keep in the back out of our mind while we're doing these equations. Alright, so the first equation here, I know that I have a root, or an intercept at x equals 3, so that's going to be x plus 3, that will cause that. And over here we've got one at 6, and that's going to be x take 6. So generally what I can say is my equation y equals some a value, x plus 3, and x take 6. Alright, that's what I'm going to have there. Now, this point here, that we're looking at, that point there is in fact 0, 5. Okay, it's my x coordinate 0, and y coordinate is 5, my y-intercept. So what I can do is put that value into my equation 0, 5. Right, so y will be 5, a, 0 plus 3, 0 take 6. So if I have 3 times by -6, it's going to give me -18. So I'm going to have 5 is equal to -18a. What it means there is, now my equation, I know that my a value is 5 over -18. 5 over -18. So what we can say is that's -5 over 18. Alright, so it doesn't matter where that negative is. So therefore what I can actually then go and do the next bit, I can write the whole equation, which I can graph, y equals negative 5 on 18, and then I've got simply x plus 3, and then x take 6, I should say. Alright, so you can also, if you want to, you can expand that equation out by FOIL and then times that factor through. Right, so that's the option, but if I was trying to graph an equation, I can put that into my calculator and it will draw that graph there. Just want to just check that just to see what happens. Right, so if I quit out of there. Right, so if I go y equals, just clear this function. Right, so negative 5 divided by 18. Right, and then we'll go bracket. It's going to be x plus 3, and then x take 6, take 6, you have to use that take, and then we graph it. Looking at my function there, cuts at 3, goes through 5, cuts at 6. That's my function. Okay. Now, some things that we know, just to double check that that actually is correct, we know that AB is negative, so that means it's got that sort of shape, and we've got our two intercept points, so that makes sort of sense. Now over here, if we've got this function over here cutting at, say, 3, going through this point over here, which is 4, right? Same process. Now, here, that means that I have a root at x take 3. But because it's touching the axes, I know that's a repeated root. X take 3. Right? So this is my y equation. Y is equal to a x take 3 squared. Right? That's what that means. Now, that point again, it could be another point as well. So we could say 4, or we could say this point over here, which is 6, 4. Might as well make it symmetrical there. Okay, so if I was going to put that point in there, I've got 6, 4. I'm going to substitute that into the equation, so therefore that's going to be, my y value is going to be 4. My x value is going to be equal to 6. And so when I do that, I've got 6 take 3 squared. So now I've got 4 equals 9a. So therefore, a is equal to simply 4 ninths. And so then my whole equation over here is going to be y is equal to 4 on 9 x take 3 squared. Alright, so that's the second example. Right, and again I could graph that equation over here. Now the third example here we're going to look at is when we have the case where you have the vertex point given to you. If you get given the vertex point, then you need to use the equation in the other form. Right, so the other form is simply using y equals, and then what you'll do is you'll put a, will be x, take the x coordinates, that's going to be minus 4, and then it's going to be simply, and that's squared, and then it's going to be plus k, which is going to be minus 3. So that's my equation there. Again, I'm going to use a point that's similar to both things, so that's going to be 0, 6. So I'm going to put that point 0, 6 into the equation, and that will give me 6 is y, a, 0 take 4 squared, take 3, so that's going to be 16, negative 4 squared 16, and then I'm going to bring the 3 across, 6, that 3 is going to go across and become plus 3, so therefore 9 is equal to 16a, therefore a is equal to 9 divided by 16. So my equation here will be y is equal to 9 divided by 16. Alright, it will be simply x take 4 squared take 3. Get the idea? Let's do another very quick one. So here's my function. I have a graph like this. Okay, it's going like that. Actually, no, I'll change that. So here's my function. My graph goes something like this. Okay, I've got an x coordinate there of -3 and a y coordinate of 5. And it goes through this point here, which is 2. Alright, so it could be any point. Again, so I've just put into the equation y is equal to a. It's going to be x take -3, so that's going to become x plus 3. We square that, and it's plus k, which is 5. Remember, these values here are h and k in the definition that you've been given. So this point over here that we've got is 0, 2. That point there. Put that into the equation 0, 2. Right, so y is equal to 2. And x is equal to 0 plus 3 squared plus 5. I'm going to bring that 5 across, and that will become take 5. Now I'm going to have 2 take 5 is -3 is equal to, now 3 squared is 9a. So therefore, a is going to be equal to -3 divided by 9, which we will write as -1/3. So now my equation will be written as y is equal to -1/3. Right, simply x plus 3 squared plus 5. Again, if we're thinking about that, anything that's got a negative a value should have an upside down shape. Anything with a positive a value should have a U shape. So now we've got a situation where we can use either of these types of curves. So if we get given the intercepts, as you were shown in these examples here, get given the intercepts, you use the first form, which is that x take alpha, x take beta. And if you get given the vertice form, then you use the equation y equals a x take h squared plus k. Alright, so really this is the important bit, is being able to get from the actual graph to the equation, because that's what we're trying to do, is model some curves to actually find the equation so we can do some stuff with that. So you need to practice these, make sure you get really good at it.